Do you think the Irish Guard and immigration is going to know the difference between a Vietnamese person from Ho Chi Minh or not? No, I don't think so.
But also, it also has a difference in size.
If you say so.
Because I never find anyone before.
Oh, you're special.
Yeah.
You're special.
And also the special of special.
The special of special.
Yeah.
Right.
One in the world.
Yes, that's true. No one is quite like you. Alright guys, we'll have to continue without those Frappuccino boys.
No.
Come on, I'm not pushing you that hard, am I?
We have to wait for this.
What?
We have to wait for this.
No, we don't.
Stephen,
What? What's your question?
in the future, do you ever be like a foreign
What do you mean?
today?
Oh, today? Oh, you have to be very, very bad to make me very angry.
Because they are so bad. I nearly had to go to the hospital.
Really?
Yeah, I have to.
Really? Wow, okay. That sounds scary. No. You have to be very, very bad to make me very, very angry, which sometimes happens.
Wait.
Well, this guy here is getting pretty close to it.
But you still smile.
Yeah, but maybe not for long.
What?
Huh?
Next.
Math.
Huh?
Math.
Yeah.
Newton.
Yes. Yeah. Thank you. Newton was not only physics, he also had some maths rules too. He was a pretty smart guy. At last.
We're done with integration.
For the moment, then we'll return to it.
The basics? No.
Yeah.
Ooh, nice.
You have to learn them.
Where's yours, Lee?
I
يعني YouTube and
You gave up on frappuccinos?
Was that my stomach? Were they helpful?
The YouTube things, yeah.
Yeah, you don't usually have so much dairy in China, yeah? Chinese diet, not so much milk. Huh?
Same as the
Really?
China has everything.
I thought Chinese...
Yeah, has everything, but
Everything.
do you guys drink milk?
What?
Do you guys drink milk a lot?
Yeah?
Yes?
Well, guess China has changed a lot.
Since the last time we visit?
Since I never visit.
I'll tell you. I know a very nice way, but do you know what I found out today?
What?
China produces a material called China.
What is that material?
It's...
What?
Yeah, no, I know what it is. It's for plates and cups and
Yeah.
Oh,
things, yeah.
but that place, the place that I made that,
Yes.
it's called Tongnan,
Oh.
and it's like China.
Ah.
It's like capital state, China is country, but
Yeah.
the smoke capital state, the smoke
See.
is that.
Oh, I see.
China.
So it's China, not China country, China, this little town.
Yeah, this is, it's mostly.
It's like Ireland, and then
Yes.
Yeah.
Ireland.
Yeah.
And these are different places. Interesting, very interesting. Okay, so as I was saying, even though this is called Newton, it's not physics, it's maths. Like I said, Newton did many things. So, let's have a look at the Newton-Raphson method.
An apple fell on his head. You saw him?
Yeah. New chapter, in fact. Okay. Here's the problem. Guys, ambassador, please. Thank you, Ambassador. Right, so now, how did we find the first root of a cubic? So when I don't give you the root of a cubic and you need the root,
Make the equation
between 3
Yeah.
over minus 3.
yeah. But of course, in real life, it could be anything. Not only that, in real life, we have more difficult problems to solve than just cubic. So is there some method where we can use guessing to get the answer, but I suppose what I want to say is there a method of guessing the answer, but each time you guess, your answer gets better? So previously when we guessed, we tried x equals 0, x equals 1, x equals 2. But we would like a method where we start with x equals 0, and the next guess is better than the last guess. That we have a way to move to the right answer without going past the right answer. Do you understand the idea? So, anyway, this is Newton-Raphson's method. So here's the idea. You start off and you make a guess. I'll call this guess x0. Is this the root? No. Here's the root here. So we want this, and we start here. So Newton's idea was, you draw a straight line up to the curve, and then here you get a tangent. Remember tangent? What's special about tangent? Meets only once. And then you see where the tangent crosses the axis, and this is the second guess. Is this the root? No, but it's closer. And what happens if you do it again? You go up, draw a tangent, and it's closer again. So by drawing tangents, you can approach the root.
But that means you're never gonna get it.
Exactly, but you can get extremely close to it. For example, if this was 2, then this x2 might be 1.99. You're right, you will not get at it, but it's better than just blindly guessing. So let's try and get a formula here. Let's just go back to this step. Right, so if this is x0, then this point here is fx0, if this is y equals fx. So this is the point here, x0, fx0. So can you please write this proof down as I'm doing it? This chapter is important because it is what your coursework 2 is about.
Oh, out of all the topics in the second semester, the only one that I've never studied before.
That's how I roll.
I hate graphs.
Then you will really not like your coursework 2.
But like, if we just make y equals to 0 and
Okay.
solve and get the exact
No, you
answer.
see, but you make it sound easy. Just make y equals 0 and solve the difficult equation. Like that.
Yeah.
No. Because I could come up with some crazy equation here. X cubed plus the square root of x plus sine x minus blah of x
Yeah, bro. we
equals
have
0. Just solve it.
graphic calculators and then that's it.
But I remember
Sorry, Mr. Newton did not have a graphical calculator.
Don't care what you
coursework
do.
2 was about integration or something like that.
Oh, yeah.
No.
Yeah.
Oh, 2, yeah, not 1.
Integration with graphs. And, yeah. Okay, can I continue? Oh, goodness. Well, can I at least go down a little bit to here? Right. So how do we get the equation of this tangent line? Y equals mx plus c. Who remembers what the m is for a tangent line?
Slope.
Thank you for stating the obvious, Mr. Obvious.
What did you ask?
How do we get the slope of a tangent line?
It's parallel to the...
No, stop talking. This is totally wrong.
Perpendicular to... No, it is parallel to, yes.
No and no.
The slope
Right
of
on the
the
point.
tangent.
True, but not for a tangent line.
Do you want y2 minus y1?
No. because we only have one point.
You integrate, you differentiate, and then you put that value in.
We differentiate. So it's the derivative at x0.
And then we get the derivative at x1.
Etc.
And how many x's do we?
Patience, young one. I'm getting there.
Oops, sorry.
So y equals f derivative x0 x. Now don't say something stupid and just think before you open your mouths. How do you find the c? No, you be quiet. Someone else. How do you find the c? Huh? Substitute in what point? Well, you only have one point. What point? Please.
x0, f(x0).
Yeah, so now you get fx0 equals f derivative x0, x0 plus c. So c equals fx0 minus f derivative x0, x0. So that can go back in here. And we get y equals f derivative x0, x, plus fx0 minus f derivative x0, x0. Now that's the tangent line. And we want to find where the tangent line crosses the x-axis. So, how do we find out where the tangent line crosses the x-axis?
So that's y equals 0.
Y equals 0. So, 0 equals f derivative x0, x, plus fx0 minus f derivative x0, x0. So we get f derivative x0, x, equals f derivative x0, x0 minus fx0. And then I should divide by f derivative x0, so I get x, the root, equals x0 minus fx0 over f derivative x0. But what did we call the root of the tangent in the graph?
Root of the tangent.
Yeah, what did I call it on the graph? Look at your graph.
X equals x1.
I called it x1.
Yeah.
So we end up with this. x1 equals x0 minus fx0 over f derivative x0. So if you guess x0, then Newton said the better value, x1, you can get using this. But then you think, well, wait a second, can't I just take that value and use it again? Because what you would like to do is then use this value and repeat, and then repeat. So what will happen is you kind of zoom in on it. So you can actually write the formula like this. And this is Newton's formula, or Newton-Raphson, because the other guy was called Raphson. xn plus 1 equals xn minus fxn over f derivative xn. And I shall demonstrate its power in a moment. Have you seen this formula before? Has anyone seen it before? What is the name of this type of formula I wrote on the board that you did in semester 1?
Sequence and series.
Yeah, but this is a what type of sequence? A what?
No, I think it is a
Geo-arithmetic? No.
Arithmetic?
Arithmetic geo? No. Neither is it arithmetic nor geometric.
Recursive?
There we go.
Yeah.
It's a recursive sequence.
Because you use the value and the...
Yeah.
Before and after.
But that's not fair or nice.
Well,
Coursework 2 is about this,
Yeah.
which is sequence and series. Coursework 1 is about...
I just want to give you another equation that should help you out with coursework 2. I find that if you keep this in mind, It would really help you with coursework. Well, not just coursework too, but a lot of things. Yeah? Is okay?
That looks like a T.
Which one?
The R.
Oh, sorry. Just to prevent any confusion. It's okay now?
Point for it, right?
I think a tattoo somewhere where you can constantly see it would be helpful as well. Can I show you how to use this formula now? This is recorded, you don't need a picture.
What's not talking?
Who are you Snapchatting? Yahya?
No. My friends.
Oh, I forgot to set up the live YouTube channel for him. Anyway, can I scroll down and show you how to use this formula? So let's pick an example where we know the answer, okay? What is the root of, let's say something like fx equals x squared minus 4? Well, that's x squared minus 4 equals 0. So what's the answer here? 2 or minus 2. Okay. So let's test it out. What you do first is you make a guess at the answer. Now let's pretend we don't know the answer. Let's pretend, I know it's difficult, but let's pretend we're stupid and we don't know the answer. So we'll guess something like, something stupid like the answer is 100. Is it 100? No, we are way off. Way off. Newton said, if you know the derivative, you can improve. The formula is xn plus 1 equals xn minus fxn over f derivative xn. So that means xn plus 1 equals xn minus xn squared minus 4 over 2xn. Can you see that? So let's try. Let's start with x0 equals 100. So that means x1 will equal 100 minus 100 squared minus 4 over 200. Yes? Let's see what the calculator says. Okay, so, 100 minus 100 squared minus 4 over twice 100. Yes? So, let's see what we get. 50.2 is what I got. So, we have, this is equal to 50.2. Now, is that the answer? Oh, thank you. Is that the answer? No. What happens if we try it again? So I get 50.2 minus 50.2 squared minus 4 over twice times 50.02. Sorry, that's 02. You get 25.05. Let's try it again. 12.6. Try it again. 6.46. Again. 5.4. 2.34. Well, you see how we're getting very close.
Just keep clicking.
2.02. We're zooming in on the answer. But look at this. 2.0001. X9. How many zeros have I got there? 1, 2, 3, 4, 5, 6, 7, 8, is it? So I'm sure this one will round off. Dun, because the calculator rounded for me. Now, if
Press
you...
it again, press it again.
Nothing will happen.
Again. Wait.
What? Press it again?
So,
Just like electricity.
we have to get an answer to make the bracket 0.
Yes. Which, if you realize it, that means making this 0, which is what you want to do.
Fx, making fx 0?
That's our goal. We're trying to get the root.
Oh, wait, no.
What?
What does it mean when fx equals 0?
You know dang well what it means. It's the root of the curve.
The root of the curve fx equals 0.
And y equals 0.
When
Yeah.
y equals 0, boom, boom.
So, after using the formula 10 times, even though we were totally wrong, we got to the answer. Now, if we were to guess one by one, starting at 100, how long would it take?
100 times.
Well, we only have to get to 2, so 98 times. So, it's a lot quicker. Yeah. Now, I'll give you one to try using this method. Take an equation like this.
What if
Yeah.
I'm really smart and the first guess I'd make is the right answer?
Then you only have to do it once.
I still have to show the formula?
Yes. Let's say sine x. Well, no, I don't want to do sine x. Something else. Ex plus x minus 2, I think, would work. Now, before you do this, notice how, Faisal, it is impossible for you to use algebra to solve this equation. There's no way you can use algebra to solve this. There's no way. Because when you try to, watch what happens.
Yeah, you...
How can I cancel the e here?
Yeah.
With a log.
Yeah.
How can I cancel the log here?
With an E.
Right? Now, before you start, Newton-Raphson's method will not always work. Newton-Raphson's method will not always work. Can you give me some examples, maybe, of when it won't work? So Newton-Raphson's method...
Me. When the graph never intersects.
Yes. Yeah, so the first instance when Newton-Raphson doesn't work is the bloomin' obvious, when it doesn't actually have an answer. Correct. Then it will not work to find the answer that doesn't exist. Very good, Faisal. I shall give you 2 gold stars. Can anyone give me a better answer? Now, I suggest look at the formula. Look at the formula.
Then don't ask if you want to know. I don't want to answer.
No, I'm not convinced you really thought about it. Go on, what's your answer?
If the gradient of the thingy
Yes, the
on
thingy.
the graph
Yes.
doesn't increase or decrease.
Nearly. Nearly.
Doesn't.
No.
Like,
No.
graphic.
No. It doesn't, Newton-Raphson's method doesn't work if you hit a turning point. Because if you look at the formula...
Well, it's a constant gradient, yeah.
No.
When the gradient is 0.
Yes. Because what will happen is you're dividing by 0, which is bad.
Oh.
And what that represents is this has happened. Tangent.
Boom.
Tangent. Bam. Off to infinity. So that's one problem.
Nice.
And the third problem with Newton-Raphson, as you notice, is it only gives you one answer, even though there might be 2 or more answers. Example, the one I did, what was the answer I got? Yeah, we got 2, but we missed -2. So Newton-Raphson has advantages, but it also has disadvantages. but the advantages are much greater than the disadvantages.
I hope when I'm older and I have kids, my kids will go through a better education system. I really hope.
This, you know,
I really hope.
I got to give you a little point here. Teachers love hearing that from their students, especially in the middle of class. There's nothing that makes me feel warmer on the inside than one of my students saying this.
I'm really serious.
Oh no, that just for music to my ears.
It's
Yeah.
way worse over there.
China has a great education system.
No, they have a good curriculum, not system. System is bad everywhere.
Maybe we need to flip back to my formula for earlier. Where's it gone now?
I have it written in my
You do it,
book.
okay.
Trade was not equal.
Yes. Now you see, you're distracting me. Can you try Newton-Raphson's method to see? Oh yeah, wait. So, what I need to show you is before you start Newton-Raphson, you want to check if there's an answer. So one way you can check is, if one value is negative and one value is positive, then there must be a root in between, because you went from the negative to the positive. Do you understand? So, let's check on our calculators. I'm going to, let me just think here, 1 plus x, so that's 2x plus 1, so 2x, hang on, 2x, let's just try 0. If I put in 0, I get E0 plus 0 minus 2, which equals minus 1. If I put in 1, I get E1 plus 1 minus 2. That's 3.7 minus 2, 1.7. Now, I have proven there's a root here, because if you look at the graph, at 0, what did I get? I got minus 1. And then at 1, what did I get? 1.7. So there must be a root in between the two. Can you see that? There must be a root. They sometimes ask you to do this in the exam. So to make sure you get full marks, you must also say, since f0 is negative and f1 is positive, that means there's a root somewhere between 0 and 1. Yes, so what would be a good number between 0 and 1 to start at? Guess
0 and 1.
what number between 0 and 1 will be a good number?
0.5.
Very good, yes. 0.5. So I want you guys, using this and this, use Newton-Raphson once, just once, to give me a better value of the root. Go. Got an answer, Andrew? No. What happened?
I don't trust my answer.
What did you get as your answer? Go on, what you get?
Greater than 1.
Yeah, you're right not to trust it. Right, let's have a look. So Newton-Raphson said xn plus 1 equals xn minus fxn over f derivative. So, let's start with, what did I say, 0.5, wasn't it? So that's answer minus fraction e power answer plus answer minus 2 over e power answer plus 1. 0.44.
let's say it's the fourth try. Can we just show them the first one and then?
No, in the exam they want each one seen. In the exam, however, they will tell you how many times to use the formula, typically twice. So if I do this one more time, still 0.443. Huh? Yeah. Well, I just want to see what happens if I do it a few times. Oh, I only needed 3 times and I got to the answer. So if you put 0.443 into this, you should get roughly 0. Let's finish by testing that out. So let's see. Watch. Well, let me just see. 0.4429, we'll say. Okay. E power 0.4429 plus 0.4429 minus 2. Do we get 0? Close enough. 0.0001. Do we have all the answers?
What do you mean all the answers?
Are there more roots? Possibly.
Yeah.
One way we can know if there's more roots is by looking at the turning point. For example, yeah, well, I'll give you an example. Here, we could find the turning point. No, because discriminant's only for quadratics. So here, if the turning point is below the axis, then there's a chance that there's 2 roots because it turns. Possibly. Now, if there's a turning point below and above, there could be 3 roots because it could be like this. Now, it's not guaranteed there will be 3 roots because you don't know what happens. This could happen. It could go turn, 1, 2, and to infinity. Okay, so if I look at this one, let's see, derivative is ex plus 1 equals 0, ex equals minus 1. Does this have a solution? No, because when I put log on both sides, do we have log of minus 1? So this means no turning points, which means the graph is just increasing, no turning points. So I feel like I have the only answer, because there's no turning point. If there was a turning point, there might be another answer, but there isn't. So I think I have the only answer here. Did you just say cute? Cool, yes, that's better. Okay, this is a very common exam question, and it's important. This chapter, this new chapter we're studying today, is important for your coursework too. Remember, life not equal fair. Now that I have suitably demotivated you, we can end the class. Yes.